Deforestation is the act of cutting down large areas of forest. Deforestation on a massive scale has implications in terms of the hydrologic cycle and global climate systems, altering both regional and global weather systems. In this video, we'll focus on how trees are intimately linked to the hydrologic cycle. These links start where trees uptake water from the ground through groundwater and surface runoff. They then return the water back to the atmosphere through a process known as evapotranspiration.
The hydrologic cycle, also known as the water cycle, transports water throughout all of Earth's systems. The processes of evaporation, condensation, precipitation, surface runoff, and groundwater infiltration all play a large role in this global cycle. Transpiration is when water is released by plants through plant leaves, joining the atmosphere as water vapor. Water also evaporates off of ground cover, such as soil. Evapotranspiration is a collective term combining the processes of evaporation and transpiration. Up to 80% of precipitation onto Earth's surface is returned to the atmosphere through evapotranspiration, where it condenses to form clouds and returns back to the Earth as precipitation. Officials at NASA's Earth Observatory describe this process as a perpetual self-watering cycle. Deforestation of the Brazilian Amazon is largely the result of the global demand for agricultural commodities such as soybeans, corn, and cattle. Large tracts of forest have been cleared and converted to large-scale pasture and cropland. Forests have the capacity to store larger volumes of water than livestock and cropland pasture. Because of this, deforestation has been linked to alterations in the hydrologic cycle due to decreasing rates of evapotranspiration from reduced forest cover.
The next segment focuses on scientific research that provides the evidence that is used to support the claim that deforestation is altering hydrologic cycles and in turn global and regional weather patterns. In an ironic twist, the research doesn't come from work done here on the ground by humans, but actually from space. From Earth-orbiting satellites and geostationary satellites, scientists have been able to collect a veritable cornucopia of data used to support the claim that deforestation is linked to alterations in the hydrologic cycle and regional and global weather patterns.
Remote sensing involves the use of satellites that obtain data about the Earth's surface. These satellites are equipped with scanning devices that detect a variety of wavelengths of light on the electromagnetic spectrum. These technologies allow researchers to compile composite information that reveals detailed information about the physical and chemical composition of the Earth's surface. The case studies that follow involve the use of 3 satellite-based remote sensing technologies. Landsat scanners combine visible and infrared light to reveal detailed information about the composition of Earth's surface, such as carbon and water content in ground-level vegetation. Heavier scanners sense the visible, near-infrared, and thermal infrared wavelengths of the electromagnetic spectrum to determine cloud cover, precipitation, surface hydrology, and vegetation data. MODIS operates on both the optical and infrared wavelengths of the electromagnetic spectrum and can be used to determine land use and land cover type. Ichi, Maruyama, and Yamaguchi use Landsat and AVER data to study the relationship between deforestation and hydrology in the Rondônia state of the Brazilian Amazon. During the 10-year duration of one of their studies, the Ji-Parana River Basin experienced a 20% reduction in forest cover. During this time, annual evapotranspiration decreased 200 millimeters. The researchers assert that observed changes in the hydrology of the forest in the Ji-Parana River Basin suggests a drying trend. They propose that this region could be at the start of a conversion from tropical rainforest to tropical grassland. Using Landsat satellite imagery, as well as atmospheric computer models, Lawton and his team of researchers determined that deforestation in Costa Rica's Monteverde tropical montane cloud forest resulted in a reduction of cumulus cloud formation. The conversion of forested land to pasture and cropland generally reduced evapotranspiration, thus reducing cloud formation. Lawton and his team explained that satellite data coupled with global climate models show that deforestation could reduce rainfall and expand the duration of the dry season in tropical rainforests.
Did this presentation provoke questions about the future of our planet? Are you wondering what you can do to reduce global deforestation? Well, perhaps you should think globally and act locally. What can you do in your community to reduce deforestation in northern Alberta, Canada, in Borneo in Indonesia, or in Brazil's rainforests in the Amazon? Please visit my blog and make a comment sharing what you're doing to think globally and act globally.